right, here we go. Number 3. Okay, number 3 says find the inverse of the matrix A below. So A is the matrix. Oops, sorry. It scrolled a little bit. Don't want that to scroll. 1, 6, 4, 0, 2, 3, 0, 1, 2. The only way to find the inverse, the only way to find the inverse of this matrix here is to then rewrite it 1, 6, 4 with your dotted lines, and then 1, 0, 0, making the identity matrix on this right hand side, 0, 2, 3, 0, 1, 0, and 0, 1, 2, 0, 0, 1. So what we're going to do is we're going to make the left hand side become the right hand side. And good news is a lot of this is already ready. I mean, we're almost there. So if you look at row 1, row 2, and row 3, the very first thing we want to do is the Gaussian method, which means we want to get all these diagonals right here to be 1s and 0s underneath them. So you notice we have a 1 here and a 0 underneath and a 0 underneath that. That's perfect. That's a great way to start. We need to get this 2 to be a 1 next. That's our next step, is get that 2 to be a 1. So if you multiplied by a half, so if I took 1/2 times row 2 and replaced it with row 2, then I would have my 1 where I want it to be. So that's a 1. This is going to become 3/2. This is going to be 0. This is going to be a 1/2. This is going to be 0. We didn't do anything to this guy right here. He stayed exactly the same. Now, what I want is I want this right here to be a 0. So if I just subtracted, so if I took row 2 minus row 3, and that became then row 3, then we'd be exactly where we wanted to be. So I get, top row doesn't change, 1, 6, 4, 1, 0, 0. Second row doesn't change, 0, 1/2, 0. And now the bottom one becomes 1 minus 1 is 0. 3/2 minus 2 is negative a 1/2. And then 0 minus 0 is 0. 1/2 minus 0 is a 1/2. 0 minus 1 is negative 1. Okay, so all it is, I took row 2 minus row 3 and made it row 3. Now, I want this one right here, I want that to be a 1. So if I multiplied row 3 by negative 2, so if I took negative 2 times row 3 and let that become my new row 3, then I'd have exactly what I want, and I'm really getting close now. So again, the top one doesn't change. Second one here doesn't change. But the bottom one now is going to change. It's going to become 0, 0, negative 2 times negative 1/2 is 1. Negative 2 times 0 is 0. Negative 2 times a 1/2 is negative 1. Negative 2 times negative 1 is 2. Okay, so bottom row is done. Now I just need to work on getting this one right here, this 3/2 here, to be a 0. Well, that would actually not be too difficult if I took a negative 3/2 times row 3 and added it to row 2 and let it become my new row 2. Okay, so that's going to give me, I can already feel it, I'm going to run out of space, but that's okay. Maybe we can scroll here in just a second, we'll see. That's going to give me negative 3/2. Okay, so the top row doesn't change. 1, 6, 4, 1, 0, 0. Bottom row doesn't change. 0, 0, 1, 0, negative 1, 2. Middle row is going to change. So negative 3/2 times 0 plus 0 is 0. Negative 3/2 times 0 is 0 plus 1 is 1. Negative 3/2 times 1 is negative 3/2 plus 3/2 is 0. Negative 3/2 times 0 is 0 plus 0 is 0. Negative 3/2 times negative 1 is 3/2. 3/2 plus 1/2 is 4/2, which is 2. Negative 3/2 times 2 is a negative 3, plus 0 is negative 3. Okay, so second row done. We are ready to work out this last row. So what we need to do is we need to get this 4 here to be a 0. Okay. And then we need the 6 to become a 0. Well, the only way to get the 4 to be a 0 and not change anything else up here is to take the last row and multiply by negative 4 and add it to row 1. So we're going to take, so I'm just going to see how far I can, hey, I can scroll pretty good here. So I'm going to write this down again. So this is where we're starting, 1, 6, 4, 1, 0, 0. Then we had 0, 1, 0. Oh, 0, 1, 0. And then this one was 0, 2, negative 3. And then the bottom one was 0, 0, 1, 0, 1 half, negative 1. Okay? And I just said what we're going to do is we're going to make this 4 become a 0. The way we're going to do is we're going to take negative 4 times row 3 and add it to row 1 and replace our row 1. So we get then, when doing that, 0. So negative 4 times 0 is 0 plus 1 is 1. Negative 4 times 0 is 0 plus 6 is 6. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 0 is 0 plus 1 is 1. Negative 4 times a half is negative 2. Plus 0 is negative 2. Negative 4 times negative 1 is 4. Plus 0 is 4. Then we still have this one, 0, 1, 0, 0, 2, negative 3. And of course 0, 0, 1, 0, 1 half, negative 1. One last row performance here and we are done. Okay? So we're going to take, we now need to get rid of this 6. So if I were to take negative 6 times row 2, add it to row 3. It's not row 3, my bad. Oh, whoa. Let's see if we can erase that. We don't want row 3. What we really wanted there was row 1. It's going to become our new row 1. Okay? So we get negative 6 times 0 is 0. Plus 1 is 1. Negative 6 times 1 is negative 6 plus 6 is 0. Negative 6 times 0 is 0 plus 0 is 0. Negative 6 times 0 is 0 plus 1 is 1. Negative 6 times 2 is negative 12. Minus 2 is negative 14. Negative 6 times negative 3 is 18. Plus 4 is 22. Okay? Then we have 0, 1, 0, 0, 2, negative 3, 0, 0, 1, 0, 1 half, negative 1. And folks, we are done. There, right there, is the inverse. Okay? Awesome. Okay, let's do another one. Let's do number 4. Number 4 says, solve this system. But they do make it kind of, they do give you some stipulations to solve it, okay? So the system looks like this. This is number 4. Uh-oh, where's my pen? There it is. This is number 4. It says x plus 2y plus 5z equals 1. And then 2x plus 3y plus 8z equals 3. And then negative 1x plus 1y plus 2z equals negative 3. And they tell you that A is equal to the matrix 1, 2, 5, 2, 3, 8, negative 1, 1, and 2, which is this guy right here in a matrix. Okay? Then they tell you the inverse of that guy. They say the inverse is 2, negative 1, negative 1, 12, negative 7, negative 2, negative 5, 3, 1. Okay, that's awesome. That is awesome because, now watch this, okay? Watch this. So in other words, we know, in sense that this is A. This one over here we could call B. And then the variable matrix, which would be right here, which we could call X, Y, and Z if we were to write it in. So to get rid of A, we need to multiply by its inverse. Now remember, matrix multiplication is not commutative, so if we multiplied by the inverse over here, okay, these would cancel each other, leaving us with just X, Y, and Z. And that would give us A inverse times B. So that's the same thing then as, let me scroll down here just a little bit. 2, 12, negative 5, negative 1, negative 7, 3, negative 1, negative 2, 1, times 1, 3, negative 3. And great news is, hold on one second, folks. Sorry, I just had to kill a hornet. Anyway, so this is a 3 by 3. This is a 3 by 1. We can multiply them. The resulting matrix is going to be a 3 by 1, which is what I want because I want to find x, y, and z, which is a 3 by 1, and I'm going to get out a 3 by 1. So to find row 1, column 1, I'm going to take row 1 times column 1. So I get 2 times 1 plus, so this is row 1, column 1, across the left, negative 1, down with the right, times 3, negative 1 times 3, plus cross to the left, negative 1, down with the right, negative 3, so negative 1 times negative 3. So I get 2 plus negative 3 is negative 1, plus 3 is 2. So that one's a 2, so x equals 2. Now to find row 2, column 1, I take row 2 times column 1. So 12 times 1 is 12, plus negative 7 times 3 is negative 21, plus negative 2 times negative 3 is 6. So 12 plus negative 21 is negative 9, plus 6 is negative 3. So there's y. Y is negative 3. Last is to find row 3, column 1. So I'm going to take row 3 times column 1. Start with the negative 5 times 1. That's negative 5. Plus 3 times 3 is 9. Plus, across the left, 1. Down with the right, negative 3. 1. It's a negative 3. Negative 5 plus 9 is 4. Minus 3 is 1. And z is 1. And there's your solution. And you're done. Okay? I'll do one more video with number 5, and we'll be done, guys. Nice job.